This video is to teach how to solve one-step equations. Take a look at what's missing in this first problem. Think about what you would add to 14 so that it sums to 0. You'd want to be adding the opposite of 14, negative 14, and 14 sum to 0. Let's look at one more. What do you add to negative 37 to sum to 0? You'd be adding negative 37's opposite, positive 37. Let's try a couple more that might involve an extra step. What's missing here? Well, first you add together the 10 and the 7, and then think, what do I add to 17 so that it sums to 0? It doesn't even matter if the open piece is in the middle. You still are going to start by adding 4 and negative 3. You get 1. What do you add to 1 so that it sums to 0? So we want to keep this idea of how you, get rid of a number and make it, in essence, make it sum to 0. As we look at solving this one-step equation, we're trying to solve for x, which means we want to isolate the variable x. We don't want the plus 7 on the left side of the equation. We want only x on the left side of the equation. So what I want you to think about now is, what do you add to 7 to get 0? We want it to 0 out. We want it to be gone. Well, the inverse of adding 7 would be subtracting 7. But you need to think of that equal sign as if it's that scale in your science class that has the two plates, one on the left and one on the right. If you remove 7 from the left side, that scale will not be equal. It will not be level anymore. So you must remove 7 from the right side also. So again, think of the equal sign as if it's that scale in your science class where the left side of the scale holds the x plus 7. The right side of the scale holds the 10. If you remove 7 from the left side, you'd better remove 7 from the right side also. Now, I know from the beginning you all knew that the answer for x would be 3, but we're going to go through some very basic examples just so you get the idea of the formal steps, because you won't always glance at a problem and know instantly what x should be. So we just need to develop our skills for how we should be showing our work so that we always get the correct answer the first time and there's no guessing and checking. So when I subtract 7 from the left side, I'm actually going to circle it, makes it look like a 0 that's there. What remains on the left side is x. Well, I guess technically x plus 7, or excuse me, x plus 0, but adding 0 doesn't change it, so we don't even need to write it. And then when we subtract 7 from the right side, we get a 3. Therefore, x is equal to 3. Take a look at this one. Again, you could maybe guess and check what x should be, but we're going to go through the formal steps and show our work. Now, my preference with a subtraction problem is to always change subtraction to adding the opposite of what follows the subtraction sign. So I'm going to look at this and really think of it as x plus negative 14 is equal to negative 73. So when I go back to those original problems, we're trying to get rid of that negative 14. We don't want it there on the left side where the x is. We want only x remaining. So we should be thinking, what do I add to negative 14 to make it 0 out, to eliminate it? Well, negative 14's opposite is positive 14. So let's add 14 not just to the left side, but to the right side also. Think again of that scale in your science class, where the left side of the equal sign is the pan on the left, the right side of the equal sign is that little pan on the right side. If you if you add 14 to the left side of that scale, you better add 14 to the right side also. And that gets us our correct answer of negative 59. Let's try another one. See if you know what is the correct first step. We're trying to isolate the variable. We want the variable all alone. So how do we get rid of negative 19? If you said add 19 to both sides, you are correct. I think it's also, once again, always helpful to actually draw a circle around that negative 19 and that positive 19. That is a reminder to you to double check and make sure those two numbers really do sum to 0. I've seen some people write some things down that do not sum to 0. So the left side now technically is x plus 0, which we don't need to write the plus 0 because adding 0 doesn't change anything. And then after adding 19 to the right side, we get a negative 12. Multiplication works in a similar way. Only instead of trying to sum to 0, because 3 is being multiplied by x, we're trying to change that 3 into a 1 because multiplying x by 1 doesn't change anything. So the inverse of multiplying by 3 is dividing by 3. Just like in a previous problem, the inverse of adding 7 is subtracting 7. We're thinking now of the inverse of multiplication. The inverse of multiplying by 7 is dividing by 7. The inverse of multiplying by 3 is dividing by 3. So you need to divide both sides. Once again, that equal sign is like the center of that scale in your science class where the left side is equal to the right side. But if you do something to alter one of the sides, you must do the exact same thing to the other side. So by dividing the left side by 3, 3 divided by 3 is 1. And just to be clear, I should actually say 3 divided by 3 is the integer 1. 1 times x is just x. So my left side is x equal to. The right side, 15 divided by 3. The right side is 5, so x is equal to 5. Let's try another one. What's the inverse of multiplying by 2/3? Well, the inverse of multiplication is division. So yes, indeed, you can divide both sides by 2/3. And any number, whether it's a fraction or an integer, anything divided by itself is 1. So the left side becomes x all by itself. And the right side, you'll have to pick up your calculator for this, 8 divided by the fraction 2/3 is 12. Now fractions bring something a little bit different into our problem set, because there's an alternate way you could solve this type of problem. I've been using that phrase inverse. The inverse of multiplication is division. You also could multiply both sides of this equation by the inverse, or in other words, reciprocal of 2/3. Maybe you had a middle school teacher that phrased it, instead of reciprocal, might have called it the reciprocal. The reciprocal of 2/3 is 3/2. So you could choose to multiply both sides of your equation by that fraction 3/2. And any number times its reciprocal is the integer 1. So the left side becomes 1 times x, and 1 times anything doesn't change a number. The right side, carefully multiply those two fractions, or pick up your calculator if you need to, but 8 times 2/3 indeed gives you that number 12. Not many of you would have looked at that original equation and been able to guess and check and gotten the answer correctly the first time. And that's the beauty of algebra. It's going to be very important. It is going to be very, very important for you to show your work. Even if you think you can look at the problem and guess what the answer is and get it right, I want you to show your steps. Because as our equations get more complex and we end up with 2-step equations for solving, or multiple steps, we might have distribution, we might be combining like terms, we might have variables on both sides of the equation. There's no way anyone will look at those more complicated problems that we'll get to and know what the answer is the first time they try the problem, unless you follow the steps. for algebra and systematically solve for your variable x. Now please try some of the problems on the worksheet on the Moodle page.